Welcome to Data Skeptic Machine Intelligence, our podcast series exploring contemporary topics in artificial general intelligence and large language models. I think it's official now. I might even be late to be calling it now. But when it comes to ChatGPT, the honeymoon is over. There's rumors that it hit its peak and the daily usage has dropped off. I think that's only natural. When the news came out, everyone wanted to go and talk to this machine. For some, it became a novelty. For others, it became a tool. I presume we're headed for some sort of steady state, although that metric, the daily usage or length of conversations per day, something along those lines, what a powerful empirical measurement of the usefulness of a large language model. I'm pretty confident everyone I've interviewed this season, maybe everyone I've interviewed ever, would agree that ChatGPT and other large language models, Bard and all the rest, these are incredibly impressive steps forward. But are they a step forward or are they a leap forward? We try and answer some of those questions today as I interview the author of the recent paper, Deep Learning and AGI, Still a Long Way to Go.
So my name is Maciej Świechowski. I'm from Poland, and currently I'm affiliated with QED Software and QED Games. These are commercial companies. And I'm a friend of Warsaw University of Technology. I drop by once per 2 weeks maybe and have some collaboration, but not working full-time at any university right now.
And can you share some details on your academic background?
I graduated from Faculty of Mathematics and Computer Science at Warsaw University of Technology in Warsaw, Poland. And then I completed my PhD in Systems Research Institute of National Academy of Sciences, Polish Academy of Sciences, in 2015. During my master studies, I was more into 3D computer graphics and CAD/CAM and just computer science, modeling in computer science. But then I switched to artificial intelligence. And from now on, I've been working in this artificial intelligence field.
Was it a natural transition into AI or was there some motivation to explore it?
No, it was natural. I was also always basically interested in AI, and I had subjects at university related to AI also, like neural networks, for example, or basics of AI. I was already exposed to it. And it was one of my interests. So definitely it was very smooth transition. I had a lot of background already. Also during PhD, I was at, for some time, around a year, I was with University of New South Wales, the Australian university. I really have great memories of.
Well, you've been exposed to neural networks just like I was when I was in grad school, but they've changed quite a bit in that time. They're certainly more prevalent, used more places, and doing a lot more. At what point did you recognize that things were kind of taking off?
I think when it comes to neural networks, because they are obviously very old, like they date back to 70s even. During my university days, there were more like research, interesting things, but not really practically applied somewhere in practice. But I think that around 2012, I think that was the pivotal moment. Or also I've been always following what happens in game AI. And around 2012 and later 2016, when AlphaGo was created, things accelerated. Technologies such as neural networks really took off. And I have some thoughts about other technologies which might take off in the future. And specifically, I'm thinking about evolutionary algorithms, that they might become very popular in the future, I think.
Is there a particular problem you think will drive that, the way maybe Go drove Monte Carlo tree search and a little bit of convolutional neural networks and reinforcement learning and stuff? I don't think they used too much evolutionary algorithms to create AlphaGo. What's going to drive the need to expand on evolutionary algorithms?
For this thing, I don't have like particular problem which I think they will be the most suitable. But my argumentation behind why they might become very popular is the trend in computer hardware, because evolutionary approaches are extremely easy to parallelize, to distribute computations. Even in the basic construction of these algorithms, there is a population of individuals, and this population can be processed in a very distributed fashion. So I think that when our processors do not really get faster clocks at the moment, but more cores, more parallel units, then these kind of architectures, hardware architectures, are very suitable for parallel processing. And actually, the processing that happens inside evolutionary algorithms is usually too complex or too hard to just boil down to mathematical operations, that it cannot be done on GPUs as effectively as training neural networks, which are basically multiplications of big matrices, big arrays on GPUs. That's why it hasn't taken off as of yet, because it's not really suitable for GPUs, which are already massively parallel. But CPUs will be in the future, and I think that will be the driving factor. And also, evolutionary approaches can be combined with neural networks in many ways. For example, like the NEAT approach, the neuroevolution of augmenting topologies. It's quite popular in research, but it's very computationally expensive. That's why it's not very popular in applications, in real life applications. But maybe it will be one day, like a combination of both techniques.
Well, with deep learning specifically, there's a lot of optimism out there right now, even in the AI community. People thinking that perhaps, well, I think everyone agrees some major steps forward have been taken. That's hard to argue, but is it just a few more steps till we get to AGI is the difficult question. Where do you think we are on that path?
I agree that there were breakthroughs, but I think on this path, we are still far away. I would say that there are many reasons why we are still far away from AGI, so artificial general intelligence. I would separate those reasons into more like mathematical reasons or technical reasons, and more philosophical or sociological reasons. Of course, large deep neural networks are extremely effective at doing some particular tasks, but it's not what really artificial general intelligence is. And maybe I will share some points from my paper I published, but I can add new things into that. One reason why I think that we're still very far away from AGI actually is that these models, these neural networks, really require a lot of data, like huge amounts of data to be trained on. And even the general models, like this, for example, large language models like ChatGPT or other large language models, in some sense, they are universal. They can be used for various ways. But still, I believe that this approach is not very scalable. First of all, when we look at humans, children do not learn by observing millions of examples or billions of training data. They learn rather quickly. So I think there's much more than just purely example based learning like these models. And also, children, for example, can generalize, can learn many things at the same time. While these models, well, it's also very hard to learn multiple things or serve multiple purposes, because for each of this purpose, such large models would require a lot of data, and it's pure computer science or mathematics, because if you have so many parameters inside the model, even the GPT-3, which is already a bit obsolete because we have already GPT-4 and ChatGPT, even the GPT-3 model had almost 200 billion parameters that can be learned. So you have to provide a lot of data just to learn such a big model, and it's just just pure mathematics. This is how it works.
Couldn't we argue that a child, doesn't begin speaking or walking, that the moment it's born, it's getting lots of its own training data, its vision, its senses, all of its senses are coming online, and it
Yeah.
maybe even 2 years worth of data before we expect it to speak. Is it a fair comparison?
Yeah, and maybe it's also the kind of approach we have to take, like very slow learning, but very multimodal learning. So a lot of different signals have to come to us, and we have to learn multiple problems at once or at the same time or interleave this learning. One of my point also was that the current models or AI solutions are not really good at seeing analogies or having an intuition. So my PhD supervisor was interested, I remember, in intuition in games, and he also liked to define it as finding answers or like initial answers, initial good solutions very very quickly, not by doing a lot of thinking or computations. Of course, intuitions can be tested and verified for a long time, but you have this initial good guess very quickly. And I think it has to do something with transfer learning, using analogies and just having a model of the world. Of course, there is research in this trend. There is also purely specific AGI research, for example, by Ray Kurzweil. But these models, which are very like popular right now, are still, they are called also sometimes jokingly stochastic parrots. They are purely computational models that don't have this analogies, intuition, and so on built in. So I think that that's a different path to take if we aim to get to AGI.
Well, the most rudimentary machine learning that I've worked with, you have handcrafted features, maybe only 10 or 15 features, you build some simple logistic regression. It lacks context and it doesn't comprehend the problem, right? It's just some arithmetic. But somewhere along the lines, we started using embeddings, and these seem to capture some notion of context. I wouldn't say an embedding is conscious or anything like that, but it's doing something special. Could it be that there's a methodology we're going to develop that brings intuition to the table, the way we kind of get context from an embedding?
Yes, maybe, but for me, embeddings are still transformations of input data. So for me, it's not the solution yet. For me, it's just a transformation of some preparing the data for machine learning. I can give two examples. One is from our company. We were training a model to detect whether it was for a company that sells used clothes. So the users of their application would take a picture, send the picture to this company, and the company will firstly decide whether it's sellable, whether it can be sold, and also how much would it be worth to sell, like a second-hand piece of clothing. We made a model to detect whether the particular piece is ready to be sold and if it's in good condition and what the pricing should be. And actually, we trained our many pictures, and the model learned that pictures with better quality have clothes of higher prices. And that was funny, but it actually learned that many like new pieces were professionally photographed, and it learned this. And it would be nice to have a model, for example, that would tell us this. It wouldn't be our responsibility to learn why it learned such weirdly, and something is wrong, obviously. For example, the model could give us a hint. Hey, I think you made this error preparing the training data. Like, come up with an idea. That would be, for example, for me, like out of the box reasoning. That would be closer to AGI. And those models do not have this. It would be similar, for example, if we were learning some physical parameters of a I don't know, machine. Imagine that we are doing this in a moving lift elevator, and then the model could, for example, knowing us, remind us, hey, I think at that time you were in an elevator, So also your data can be completely wrong, or you have to take into account the acceleration that took place during these measurements. This is also like out of the box. But if we are just doing like the models that transform some input to output, and we don't have these capabilities. So I think much more can be done here.
Well, there are some benchmarks. I don't know of one off the top of my head, but I've seen tests of reasoning. It could be something as simple as block world. There's describe a few blocks on the table and say which is on top or which can easily be moved, these sorts of questions. And large language models are getting good at things like block world and maybe even more complicated reasoning tasks where you have to figure out, who's someone's cousin based on some logic and different puzzles like that. They're not necessarily at superhuman level yet. Could it just be we need more time and practice and the reasoning will be trained in?
I cannot say no because those big models do not stop to amaze me. They are still lacking, especially in the like visual puzzles department. So I saw papers. I don't remember them from the top of my head. Those models can be extremely good at some language puzzles or logic puzzles even, but they lack doing some connections in this visual question answering, for example, in these kind of tests. But yeah, maybe we will get there. But still, I think this is some kind of fundamental problem in the approach because those super huge models, maybe 4 or 5 companies can afford training them in such a way. So maybe we will get there, but if there are only like 5 models, super huge companies trained for a very long time using a lot of data, super high-end hardware, very costly, then I think we still need to pursue like more efficient, environmental friendly, better scalable, like better scaling solutions. That's my point. I might be wrong on this, but that's my point. I've already see how useful these big models become. For example, they can help me in programming. They cannot replace me yet, but they can really help me. Well, they switched from being funny, some code it might work or something, to being actually useful. They can make some constructions that I can take and use in my code. But for example, I also checked them if they can review scientific papers. So they can summarize them pretty well, but they cannot like review them like reviewers. I was also doing this for like reverse engineering, whether to find if some of the reviews were maybe generated by these models, and they don't do it like this. They cannot point, oh, in this line you might have an error. They take it for granted. They can summarize this paper, but they don't have this critical thinking, and they do not question reality.
Modern data teams are using HEX to 10x their data impact. HEX combines a notebook-style UI with an interactive report builder. This allows data teams to both deep dive to find insights and then share their work in an easy-to-read format to the whole org. In HEX, you can use SQL, Python, R, and no-code visualization together to explore, transform, and model data. HEX also has AI built directly into the workflow to help you generate, edit, explain, and document your code. This is the missing piece of your data science stack. The best data teams in the world, such as the ones at Notion, AngelList, and Anthropic, use HEX for ad hoc investigations, creating machine learning models, and building operational dashboards for the rest of their company. HEX makes it easy for data analysts and data scientists to collaborate together and produce work that has an impact. If you're looking for a job, you need to have HEX on your resume. If you're a data science decision maker or just a thought leader in your company, you would be derelict of duty to not check out HEX.tech. Make your data team unstoppable with HEX. Sign up today at hex.tech/dataskeptic to get a 30-day free trial for your team. There's another intrinsically human property you describe in the paper, and that's that Humans are pretty capable of explaining what their thought process is. So, let's say you were observing me play a game. Even if I did something wrong, I probably was working it out. I could tell you why I did it and my actions would make sense. Do we see these sorts of properties today in machine learning models?
Well, usually they require a lot of effort to build the explainable or interpretable layer. Of course, there is machine learning that is inherently explainable. For example, rule based systems, some expert systems. There is also like a trend to combine logical reasoning that can show you steps of logical inference with some neural approaches, like neural symbolic approaches. And that's good, I think. When we are talking about big neural networks, well, they're not really explainable. They're big graphs of computations. They require a lot of effort to build this interpretable layer, and also it's not always possible to do it. For example, ChatGPT, I don't think it can be like explained what really happened when you put a query to it and got an answer. So what really happened inside? Well, we can analyze which neurons were activated, and there will be like millions of them. To translate it to some familiar concepts, I think it's something different, but it is required because there's a lot of talking about regulating AI. I think the European Union was the first like big body to do something, and they released AI regulation law. It's over 100 pages, 100-page document. So it's really needed to have it interpretable, especially when more will be dependent on these models.
Another area that I think is really critical you cover in the write up is the vulnerability to attacks. For listeners who aren't necessarily clear on what you mean by different attacks, what sort of attack might I do on a deep learning model?
Oh, yeah, there are actually many types of attacks you can do. Let's consider that the model is learned on data like ChatGPT. It's a trained model, but also it can learn on new examples and it's like constantly being improved. So by asking specific questions, you can like program the model to the way you want to behave. Of course, it's not easy. That's when I say you want to be it to behave, it's an exaggeration because you really need to put a lot on effort, but it's possible that, for example, showing specific examples to the model, or if it's a, for example, language model, then the specific examples would be asking it specific question. If it would, for example, image detection or something, you can like show specific images and you can fool it that way, like to train it the way you want. Usually it involves having your own model, like a surrogate model, and testing what can you do on your own model, and then having attacks on the actual model. And the second case is when the model is static, so it's not trained. But also there are many ways to fool such models, and it depends on what kind of model it is. For example, if it's like, again, image detection model or video detection model, people, for example, show that when you put a small sub image on your image, but a very specific one, like crafted for this. For example, in my paper, there was an example of a banana, and there was an image of banana, and the model would correctly detect that it's a banana. But when you put a little sticker, specific colors, pixel values, then the model starts to think that it's a toaster. No human would be fooled that it's a toaster. So that's one way. But also for language models, some people found out how to put it in a like developer mode so it can answer specific questions. There are some constraints. For example, ChatGPT cannot tell you how to make a bomb or how to break into someone's house. But if you ask how to protect my house from breaking in, then it can hint you how one can break into a house. So I think that's also kind of attack, but suitable for language model. For now, this model is not very powerful. that it can lead to actually breaking in. But in the future, when these models will be more powerful and more responsible for more things, that would be a serious concern.
Well, in cases like getting ChatGPT to tell you how to break into a house by asking for defensive advice, in my mind, I'm wondering if this is comparable to the idea of social engineering. Are you familiar with that term?
Yeah, a bit. Yes, yes.
So, what if my claim was that human beings have the same vulnerability? Is it a fair comparison?
Yeah, I think so to some extent. Yes, maybe not all of them. I don't know if we can change human nature, but if we make something artificial like these models or machines or whatever, I think we should just strive to make them as safe as possible. So we cannot make human nature. We can, of course, make laws and punish people for bad behavior, and that in that way try to prevent them from doing something bad. We don't have, of course, this with machines, but I agree that humans are also like the weak points in such attacks. You probably remember the Kevin Mitnick story, the famous hacker. He wrote a book that he broke people, not machines. So yeah, I think it refers to your sentence.
Do you think deep learning is on the path towards AGI? Are these limitations you're describing just the challenges that we'll need to tackle, or are these insurmountable hurdles and we need another path to get to AGI?
Well, last year or 2 years ago, I would definitely say that we need something more, something else. Now I'm not that convinced, but I still think that it's only a component. We need something more. I would argue that for AGI specifically, not for just very advanced AI that can do many tasks very efficiently, but really artificial general intelligence and like a human like intelligence, we need something more. And I'm not sure if it's even possible to have a human like intelligence without a body and without being part of a. I'm not sure, but that's my thoughts that maybe we need something more. Maybe we need to build machines on human like on natural architecture of some sorts, because there are ideas, for example, to use DNA for storage and for computations. These ideas have been around. Maybe we will see some embodied intelligence.
Well, given that you have some expertise in the gaming AI space, I'd love to maybe pivot and talk a little bit there about what you see as the future given recent advancements in AI.
Yeah, so the recent advancements in AI do not really transfer that fast into game development. I talk with many game development companies or game companies or game analytic companies, and I noticed that game studios are really afraid of advanced AI in their games. So they are very open to use the latest scientific AI for analytics, for example, or for optimizing profits. I don't know, sales in their shops, some microtransactions, or some strategies how to publish a game, all this stuff. But actually, for controlling something inside the game, like NPCs, non player characters, or bots, they are really restrained, I would say, even afraid. So, one thing they're afraid of is that they cannot test the game thoroughly. And they are really focused on testing whatever interaction is possible in the game. That's one thing. They also don't want like non-player characters in the game to be too strong, because players will be frustrated and they probably won't be buying games because they will think that the opponents are too hard. And maybe the third one is that it still takes a lot of computations to have an advanced AI, and often in games, the requirement is that AI doesn't take more than 3 to 6 milliseconds per frame or per second. So only a small portion of resources, like computational resources, can be made available to AI in games, in video games. So yeah, so I don't see much advanced AI yet in the games, but around them. Like in the industry, yes, for analytics especially. That's a huge part. There are many analytics sites that can help you become better player and analyze things. But yeah, for controlling players, we are not there yet. But it's very interesting to see how this development, how this industry changes.
Yeah, you highlight some very interesting challenges there for sure. I had never even thought about the 3 millisecond per frame limit, that you would have to distribute the intelligence across frames in a well load balanced way. That's quite a challenge.
Yeah, you have to distribute it. It's sometimes this goes by time slicing, and it's also a technical challenge when you cannot, for example, take the whole CPU and think continuously. You have to be able to split your computations. And even in multi-threaded environments, when you would think that some of the threads can go into AI, for some reason it's still a problem. I think it's more like a technological problem than a research problem. So it will be overcome. But I hear about this all the time, that it needs to be time sliced, that there are problems with having separate threads for AI. Sometimes it's possible, but especially when the studios have their own solutions, like more advanced ones. But this is the general situation, is that it's a problem even to have a multi-threaded AI. Very practical problems which I encounter. I was involved in 2012, 13, and 14. During these 3 years, I was involved in a quite interesting, I think, research activity. It was called General Game Playing. There was a general game playing competition held annually, organized by Stanford University. And the goal there was to create computer programs that can play basically any game. It was not any game, but the only restrictions were technical. The games had to be finite, synchronous, so one player takes an action during a time, and deterministic. That's basically it. So there was no like genre restriction. The participants would make their programs, and the programs would play with each other, and rules of the game to be played were the runtime parameters. So I just ran my program. It was like a server, so it was waiting for connection from the organizers that would pair the programs that will play against each other. There was also one player games, like puzzles. Yeah, and they will receive rules. They had some time to just analyze the rules initially, and then some time before making each move, and they had to just play. So that's also, maybe that got me interested in this AGI area, or just way of thinking, because that was like AGI limited to certain class of games. One program to play many games.
Well, the paper I initially reached out to you about was titled Deep Learning and Artificial General Intelligence Still a Long Way to Go. And at least the edition I have is April of 2022. But AI news moves pretty fast.
Oh yeah.
Do you think it's still appropriate to say it's still a long way to go?
I think yes. I think it's still a long way to go. I think that AI has done remarkable progress, and it's extremely efficient in specific tasks. But when you consider all the human factors, and that's one thing I would still stand my point. And the second thing is that I need to still see how you can train the models faster, and how they can scale with more and more problems and applications. When we will have these super big models that will be extremely efficient in doing something, and they will be actually used for many things, they will generate data. There will be more artificially generated data than, for example, data generated by humans. And we will just jump into this loop that these models, the newer models, will be probably trained on data from older models. Also, it can be very dangerous to training. That's a light, that's a maybe yellow light that lights up in my head, that when we have this constant loop of newer models training on data from older models, then maybe there will be some kind of loop and, I don't know, obstacle in improving. It's also, I think, problematic potentially.
Was there anywhere listeners can follow you online, or any recommendations you have for where they can learn more about AI in games and other topics?
I don't have really big presence online, but for example, if anyone wants to find me on LinkedIn, you can try googling Maciej Świechowski or QED software. So maybe you will find me there, and I will be happy to talk, to respond, to have conversations. That's for sure. And where to follow AI? Where now there are a lot of sources. So I recommend, for example, checking on highlights or papers from top conferences. And for example, in games, you can check IEEE conference on games. There are many interesting topics there. There is also a journal, IEEE transactions on games. You can also follow more general AI conferences like Triple AI conference or ECI, for example. So European Conference on AI, because Triple AI is North American. Also HCI, Big Data Conference, ICML, that's more like research conferences. But I think you can also find interesting YouTube channels. I don't know if I can advertise any. At some point, 2 Minute Papers was a very popular YouTube channel, 2 Minute Papers.
Yeah, good recommendations all around. Well, Maciej, thank you so much for taking the time to come on and share your work.
Thank you for having me.